2. Hey, welcome back to another My Pod class. This is Stata, and this is going to be about regression. And I've also been studying very hard to kind of figure out how to do R, because several of you were interested in doing R. And so what I've tried to put together for you is a set of kind of detailed slides that will support both the Stata and the R. Now, my expertise and the effort I put into was basically just calling Michelle and say, Michelle, I don't know anything about R really. I know a little bit, but I don't have any idea how to run anything in it. So what I asked Michelle to do is get in there and see if she could replicate the stuff I've done in R, and she assures me it's doable. Is that fair?
That is perfectly fair.
So, but once again, I'd like to think Stata can beat R in this situation. We'll find out. I know she beat me with Tableau in our last video, but I'm feeling more confident today. So we're going to move right into the heart and soul of statistics packages, whether it be Stata, SAS, R, SPSS, any of those. Kind of the heart and soul of all of these is regression. And so we're making the assumption that you have certainly a general understanding of regression and how that works. All I'm trying to show you in this analysis, and what Michelle will take you through when we look at the R information, is kind of what are you putting in terms of the requests or coding, and then what kind of output do you get and how do you interpret it. So that's our strategy, I think, for today. Anything else, Michelle, you think about that we want to get done?
I think that's about it. You summed it up pretty well.
Hey, for me. All right, so let's give this a try and see what happens. One of the things that I did want to point out before we get started is that one of the biggest, probably the biggest place for you to access Stata information and Stata tutorials is out here at UCLA. They've been a pioneer out here for connecting with Stata for a long time. They have a great deal of support. You can do it both synchronous and asynchronous, but however you want to do it, this is a place to also go out and find information. Some very nice examples, and excuse me, and a good place to go if you need reference material. So I just wanted to point that out, that that's available to you all the time. So we move on to regression. And so this is the basic setup. What we did, we're trying to follow our same example. So we're using that same data set that we've used before. And so I bring it in, and then we're going to do our regression. So all you have to do is type regress wage. And in this case, the example they used in the book was the union variable. Now, there's a couple of things you can do to shortcut that command. One, all you need to use is reg. Okay, you don't need to type out regress. You can also point and click this thing, wage and union. By convention, they always have the y variable first, and you think about it as this is equal to this. You didn't need the I really. They're putting that in there to tell you if you have an interval variable or a continuous variable. So that's why that's in there. Don't really need it here. So that's the setup. All right. Now I'm going to go back. At this point, I'm going to go look at R real quick and let Michelle tell us a little bit about the next piece, and then I'll come back again and we'll take a look at the output. So how would you replicate that then in R?
So there's many ways to run a regression, and not only using different programming languages, but in R itself. So when Professor West asked me to look at this data set and replicate the regressions he had done in Stata, I first came to look at it coding, basically just writing the lines of code. And then I realized I was giving myself way too much work, and R has this add-in called Radiant, which makes it really useful to.
How do I spell that?
R-A-D-I-A-N-T. So
Radiant. Okay.
Yeah. So it's right in, when you open R, there's like a little drop down called add-ins. And when you click that and you click Radiant, it brings up a Chrome window. So basically it brings you to a window that you can import your data set, and it's very easy. And then from there, you can do different regressions. So all I did was upload that NLSW88 data set and run a linear regression with using the wage and union. So it gets the exact same results as Stata did, which is great.
So Radiant kind of gives you a capability to point and click a little bit more instead of writing the code.
Exactly. Yes.
Okay. All right. So you could go in and you requested the same data set, and you designated your Y, and this, they call it a response variable here.
Mm-hmm.
Then you're explaining it with union. And then they automatically create a null hypothesis and an alternative for you.
Yes.
So there's really not a whole lot of difference, I don't think, in terms of the way you make the command work. Okay. So for me, I would just go in, say regress wage union. Don't forget that you can also just double click over here on the right. They have a list of the variables. If you double click on this, it'll automatically put the variable in. You don't have to keep retyping the variable name. So wage and union, and then you get your output. Got to know the number of N. You need to find out if your model overall is significant, and it is. Nice to know what the adjusted R square is. It's fairly tiny. That's a technical statistics term, is tiny. And then you get all the classic kind of information that you need over here in terms of model specifications. Finally, you get your coefficients down here in the corner. My one complaint about Stata is, for some reason, I'm looking for the intercept to be at the top of the list. They put it at the bottom of the list, and they are not listening to my complaints. So I just thought you should know. And then they give you the t-tests and this, and then I put in, West created this. This is not part of the output, what my prediction line is going to be. So Michelle, go ahead and take us through the same information over here in R and how it's put together.
Yeah, of course. So right when you click that and make this regression, it spits out the coefficient for wage and union, and then their standard error, the t-value, and the p-value as well. And just that significance code, that is just showing what the different stars next to the p-value mean. So that's just like a little key for what that means, because once you have a lot more running in your regression, a lot more data points, they'll all have different significance codes. So it's good to know that.
And if you go to research projects, and you'll see this actually later in our slides, this is a pretty common, well, actually it's a very common way to indicate significance and the level of significance. So the way they've set this up is very consistent with the way folks would tend to do their research and report it. Okay, go ahead.
And then it just gives you the R squared, the adjusted R squared, and then the numbers of observation. So it kind of just sets it up a different way than Stata does, but it gives you all the same information.
And clearly after that, you can tell that Stata is far superior. So Stata 1, R 0. All right. So I don't think she's real happy about that, but that's okay. She's very tolerant. And so one of the things that you may find interesting, we tend to call it a levels kind of analysis. And so in this case, we had, they want you to think about, how do I recode variables and how we might turn those into dummy variables. And so remember, dummy variables are just those 0, 1 variables that you put in and to capture certain individual levels or events. And if you've got 3 of those, let's say you got 1, 2, 3 levels, you're always going to use one of these levels as the base in your regression, and then you'll include 2 as actual dummy variables in your regression, because this one you need to just set up as what's the difference caused by these compared to whatever your base is. So in this case, they recommend that you go through this list, and we tabbed what was their highest level of education. And so they suggested that you draw a line here and here, so we could break these into 3 different pieces: low, medium, and high education. Okay, because that was an intuition they had. And so what happens when we recode it? It looks like this. So we're going to recode that variable called grade, and this is how we want to do it. So the first 10 observations, okay, so the first 10, recode those as a 1, and then we can put in a label that says low education. Then you can put in the next group, 11, 12, and 13, assign it the number 2, and then you also get a label to go with that. And the same way, don't forget to add generate to it. You can go through the whole thing and then you're not really generating anything. So don't forget that, and that'll actually get it into your data set. And so at that point, they run grade and education again in crosstab, and they're able to validate the fact that these are lows, mediums, and highs. So what they hope to do, they were able to do in terms of the recoding. Okay. We didn't really try to do that with R, I don't think, did we? We left that one out, right?
Yeah.
And so what I tried to do here was just give you a quick look at how that education variable gets split. So remember the 2 dummy variables that Stata automatically creates for you. You don't have to go in and code it because you've already done that when you recoded the variables. But it'll all automatically select the lowest level and make that your base. And then we'll add these 2 as extra dummy variables. Okay, and that's a really nice little shortcut compared to what you might have had to do more of a brute force kind of approach. And so here are the dummy variables as they're set up. So if it's not medium and it's not high, the only thing left is the intercept, which reflects the impact of low education. So that's why you have the 3. Okay. Now, one of the things we talked about in class was how do you build models? And so I told you a way that I like to build them, and we'll take you through these mechanics and get you to kind of think about what do I look for when I have different sets of variables in each of these models. So that's kind of our strategy. And so the first thing I'm going to look at in here is, and see, you can see I used the reg instead of regression, and I've got wage and total experience. Okay, so those are the 2 pieces I'm looking at, my Y and my X. And so when I run that regression, the same kind of output you've seen before. I've got an N, I've got an O, a tiny, again, adjusted R squared, I would say. And I've got some significance both in my in the coefficients I have and down here to set up my regression model. But it worries me, okay, that as a main effect, that's not explaining a great deal. So what you usually see in models then is people will start thinking about control variables. They might then go on to think about interaction effects and so on. We'll save that for the next video. But right now you're starting to think about control variables. And in this case, the control variables well, first, here's the R part. I'm sorry, Michelle, I've treaded on your territory. So you basically have replicated it, right?
Yeah, it's basically the exact replication of what you had done in Stata, looking at the total experience and wage.
Okay.
And it gives you that R squared adjusted R squared and your N and everything like that.
Okay, now I will give you this one. Okay, the intercept does come first. So hats off to the R people for making that go first, because that does make me happy.
Okay.
So the next thing that I will do is I'll look at a model that's just control variables. So I don't even put a main effect in there. I just want to know if these are the control variables I have, how much do they actually explain of the variation in my models. So in this case, I used union, whether they lived in the south part of town, what grade did they go through. And so those are the three control variables I've got. All of them are statistically significant. You do notice that for the first time, we've got one that's not significant at below 0.001. So don't get enamored that they all have to be this. Not true. I'm pretty excited when I see that as well, because our cutoff tends to be 0.05. So we're still looking pretty good. Now the thing up here that's a little different is now we've jumped our R squared to 0.21. So our control variables are doing something. Okay, so those alone are identifying about 20%, a little over 20% of the variance in the model. And so with R, go right ahead. Oh, R wizard.
So looking at the control variables only in R with wage, grade, south, and union, you can see the coefficient, the standard error, the p-value, and as you can see, the first p-value for the intercept has more significance, as Professor West just stated, from the Stata version, and then it just gives you your R squared and adjusted R squared as well. So.
And so you're still using radiant, right? In
Yes.
doing this? Okay. So that's the way this one is set up. You're just reading it a little bit differently, but the you get essentially, well, you do get the same information. And so finally, I would take a look at what I call a fully specified model. And that's the model that's going to include both my main effect, which is this total experience plus my control variables. And what we can see now is all these things are statistically significant. And so again, you've got to interpret the signs. So in this case, if they live in the south part of the city, that's going to have a negative impact on their wages and so on. So make sure you're able to interpret the sign. R gives you essentially the same information, just in a little bit different format. So how long do you think it took to do this in R, Michelle?
To do all of them or just
Yeah,
one?
just kind of all of them.
Not too long, 10, 15 minutes.
Okay. And so I think that there's no real difference. I mean, once you got to the radiant part,
Yeah.
if you were trying to write code, that's a whole different game.
Yeah.
But
Sure.
I don't think either one of these seems to take a lot of time.
Mhm.
And so, kind of working your way through any stat package has kind of a little bit of that same learning curve. So that's why I thought it was important to kind of look at the two and compare. R is, now tell me about how expensive R is to get.
R is completely free.
That's what I thought. So, because you can't retain a student version of Stata forever.
Yeah.
So, which or any of those kinds of softwares. So, I think that's one of the things that's become really, really attractive about R and the capability. And if you're just looking at kind of the heart and soul regression, it can do what any of these other stat packages can do. Excuse me, without a great deal of in-depth coding, shall we say. Is that fair?
Yes, that is fair. I think Stata definitely has its benefits because you can go into it with a lot less of a coding background. But I think some of the things in R, you really do have to know how to code. So having the coding background for me to do a lot of the things in R is really necessary. Luckily for regressions, it does make it easy for you
Okay.
reading package.
Can you give me one example of how coding might become a little challenging?
So say you have to make changes on the data set or remove, add things to columns, things like that, that would actually require, I'd say, a lot more writing of lines of code than it would in Stata.
Okay. So anyway, there's pros and cons, and but if you're just focused on kind of the fundamental key part and the heart and soul, as I said, regression, this one, R is as good as anything. So I think what we have ultimately here is a tie, but only because we're working with just regression.
Yeah.
So one of the things I did want to leave you with today is how to do the standardized coefficients and then how I would present the data. So the only thing that you have to do to get to these standard coefficients, you just have to add this one little piece, beta. You get all the same information you had before, and then they just put the standardized pieces out here at the side. And you can do the same thing. All you had to do was, what one thing did you do a little bit different here?
So in Radiant, the only thing that's different is you check a little box that says standardized. And as you can see right there, it shows that the coefficients are all standardized. So that's where it changes it so that in the actual table of coefficients, that's where the standardized numbers come.
So clearly in this case, the Stata output is better because you see these things side by side. Oh, maybe Stata has inched ahead by just a little bit, but nonetheless, we'll go to our last slide of the day, and that's how I tend to represent the data. I always like to have models side by side, and that's why I was talking about having those different coefficients side by side. So you pull the models, you reflect your main effects. Other thing about this is a lot of people will just put in the actual variable name as it's coded into any stat package. From a reader standpoint, I would like to see a little more explanation of it. So if experience is a thing, I might also then put the variable name out there, but help your reader because we're not going to know the variable names as well as you do, obviously. And so we have that. We have our results. We've got an N set in here. Then model 2, just the control variables. If I'm analyzing the data set, I don't have an equal set of observations. So as somebody who's reviewing the work, I'd want to know where we lost those extra, not quite 400 observations. What was the missing data? And we've talked about that earlier. So why do we not have comparable amounts in the data? And then finally, I would do my fully specified model. I would be able to go in and talk side by side about the changes in adjusted R-square. That, yeah, these are comparable in terms of the same observations, and everything is still statistically significant. One other thing in here that you'd have to kind of think about, though, is what's the story on these negative constants? So interpreting those is always a little dicey, and I'm sure that your stat expert has talked about those and how to deal with them. But just be prepared, because when you set these things side by side and you start seeing signs flipping around, that's kind of a red flag and gets people to think in more depth about your models. Anything about this setup, Michelle, that strikes you as something you might want to change or something that's helpful?
I think it's really helpful to compare models side by side just because they can all have different benefits depending on what you're actually trying to look at. So I really like this is the way you reported the results.
And if you're reading any kind of research paper, you'll tend to see it like this. So with that, as always, we're hoping this helps. And we look forward to talking to you again about interaction terms next, because Stata does a pretty reasonable job of setting up the interaction terms. We'll go through that pretty fast. It'll be a short tutorial on that. The next big one we're going to do, though, is how do you look at your regression diagnostics in both Stata and in R. So that's going to be the next piece we're after. But for now, we appreciate your time. And Michelle, anything else to add?
Nope, stay healthy.
All right, she is my R expert, and she is now signing off. So between us, we'll catch up with you a little later. But thanks very much for joining us.